Hello students, today we'll discuss IB Math SL Paper 2 November 2018. In this paper you should use calculator. My name is Nariman Melim. I'm located in Baku, and here you can see my mobile and email. The main sources to prepare for exam is textbook from Oxford 2012. I recommend you to have Mathematics SL guide, but more important, data booklet, which is called Mathematics SL formula booklet. This booklet has formulas, and this booklet will be available for you at the exam. This is the cover page of the exam. Section A, question 1. Okay, let's put here divider. A group of 35 students, some take art class, some take music class. 5 of these students do not take either class, and this information is shown in the Venn diagram. So what we have, total is 35. 17 has art class, 19 has music class, 6 has both art and music, and let us see what they want. Write down the number of students in the group who take art class. So 11 plus 6, 17. One student of the group is chosen at random. Find the probability that the student doesn't take art class. Doesn't take art class is, take art class is 17. 35 total minus 17 will give us number of students 18, and probability will be number of students that don't take class 18 over total 18, 35. One student from the group is chosen at random. Find the probability that the student doesn't take art class. We did. The student takes either art class or music, but not both. So either 11, 13, and not 6. So 11 and 13 give us 24. So here we have 24 over total 35. So this question is done. Question 2. For question 2 we will need calculator, so I'll switch on calculator. So calculator is on, and let us see our steps. So first we press clear, for example. Right, okay. So first we adjust. So in the mode we should change one characteristic. Here we have start diagnostic. It is off. We should make it on. So let us make it on. So we press enter. Now it is on. So we are ready to work with statistics. So statistic, edit, start. Statistic, edit. We should insert information. So the following table shows the hand length and the height of 5 athletes. So hand length is x, height is y. The relation between x and y can be modeled by a regression line with y equals ax plus b. Find the value of a and b, find the correlation coefficient. So first we should make lists. So we do this. So we press start and edit, and we insert the data. So 20 21 enter. 21.9, enter. 21, enter. 20.3, enter. And 20.8, enter. So X column is finished. Now we go to Y column. We move to the right. So 1, 7, 8, and 0.3, enter. 185, enter. 177.1, so mistake, 77.1, enter. 169, enter. And 174.6, enter. So let's check. So 178 and 3, 185, 177 and 1, 169, okay, right. And this 21, 21 and 9, 21, 20 and 3, 20 and 8. So this is mistake. 20.8. Finished. Now we made the list. So we change mode, statistic diagnostic on. We made list. Now we are going to calculate. So we press start. And here we have to move to the right, calculate, and we are going to calculate line 4, regression line AX plus B. So we choose line 4, and here we see X list L1, Y list L2, and press enter, and here is the answer. So A equals 991, B equals minus 31.3, and R equals 0.986. So if we didn't change mode at the beginning, we will not get R, so be attentive. Right, okay, so this we did. Now next, another athlete on this sport team has a hand length of 21.5. Use the regression equation to estimate the height of the athlete. So we write our regression with A and B. Instead of X, we put the hand length 21.5. We calculate and we give answer to two significant figures. Question done. Question 2. This is question 3. Question 3. Let us find solution to question 3. So we have function, and for the graph of f, find the y-intercept. Y-intercept means that f equals 0. F equals 0 means that numerator 6x minus 1 equals 0, 6x equals 1, x equals 1 over 6, so the point of intercept is 1 over 6, 0. Done. Find the equation of the vertical asymptote. Vertical asymptote we have when denominator equals 0. So denominator equals 0, 2x plus 3 equals 0, x equals minus 3 over 2. Find the equation of horizontal asymptote. So when x tends to infinity, we can rearrange this formula in this form, and we'll get, so when x is going to infinity, we're getting y equals 3. Or you can divide by x, numerator and denominator. Here you'll get 6 minus 1 over x. Here we'll get 2 plus 3 over x. X tends to infinity. This part will be negligible. So we have 6 over 2, which is 3. Hence or otherwise write down the limit of this right. So asymptote is actually the value to which y tends when x is approaching. So we can write either the same as a, so y equals 3, or we can differentiate both parts to get the limit. So if we differentiate, we get 6 over 2, which is 3. So 2 options for solutions. Question 4. A particle moves along a straight line so that its velocity v after t seconds is given by this formula. Time is between 0 and 5. Find when the particle is at rest. At rest means v equals 0. So v equals 0. 1.4t minus 2,4 equals 0. We can logarithm both parts, and we get time equals logarithm 2,4 divided by logarithm 1,4. This is one solution. Another solution is you realize that this means that t equals logarithm with base 1.4 of 2.4. How to do it? So let's put here clear. So alpha windows, no, alpha windows. Here we have logarithm base line 5. So put here 1.4, move to the right, 2.7, 2.7, move to the right, enter, and we get 295 as before. So this question is done. There are other points. Okay, wait. There are other. Right, we should return. So we found that when the particle is at rest, find the acceleration of the particle when t equals 2. Acceleration will be derivative of v at time equals 0, at time equals 2. So we're going to find derivative. Let's do it. Right. We press math. Number 8. 8 is derivative. Okay, so we choose derivative of x over this expression. An expression is 1.4 raised to x we'll put here minus 2.4. also it doesn't matter because derivative will be 0, and this should happen at point 2, so we need derivative at point 2. and for some reason we got wrong answer. Why? Because I didn't put 1.4, I put 14. So let's return back, let's press enter, and let's correct. So I second insert, I should put here. Now it is correct, I press enter, and I got correct answer. Only now I get correct answer. So this is 0.659 meter per second squared. Right. Find the total distance traveled by the particle. Total distance will be equal to the absolute value of integral. So how we do this absolute value of integral? So first of all, alpha, Windows, line 4 is finite integral. So from 0 to 5, here we should choose absolute value. How to do absolute value? Alpha, Windows, absolute value is line 1. Now we have absolute value, so we can put here our expression 1.4 raised to power x minus 2.7, and integral is with respect to x. Finished. So it is thinking, calculating, because here is the running line. So, and see, here I put here wait, it means that it takes a long time. Answer should be 535. Yes, it is 535, so we can go to next question. The sum of infinite geometric sequence is so much, second term is so much, find the possible values of R. So question 5, data booklet, section 1.1, the sum of infinite geometric sequence is given by this formula and it equals 33.25. In the same section 1.1 you have the nth term of geometric sequence is given by this formula, it equals 798. So we copy these two formulas, and here we can see we have two unknown. R can be expressed in terms of U1, so we substitute this this can be simplified in this form, and then we, instead of R, we put its expression in terms of U1. Let's change U1 to T. We get T squared minus 33.25, okay, equals, I forgot to put here 0. So we have quadratic equation, and for this we will use calculator. So we press apps, and here you should find apply simultaneous to, here it is line 3. Then just add advertisement, so we choose 1. It is quadratic, so we don't change anything. You see here next, so we press here next. Now we put A1, A2, A3. A1 is 1, so it is 1. A2 is minus we put from here, minus 33.25. 25. Enter. And here we just can put this expression 33.25 times 7.98. Enter. So it calculated. Now solve, and we have the value. So we copy these values of, we have two solutions for U1. So U1 can be either 20 or 30.3, and for each of them we can calculate using this expression. We can calculate one value and then another value. So this is about 0.4 and this is about 0.6. So this question is done. Question 6. Right. Question 6. Question 6. Consider the expansion of this binomial. The coefficient of the term in x40 is 5 times the coefficient in the term in x38. Find k. So this is the expression of the R term. So R term, there is a formula. So we make exponent of x equal to 40, then it is when r equals 8, and coefficient will be for r equals 8. We put 8 here, and so on, so we have this expression. So exponent of x is 38, r equals 7, so coefficient will be like this. So we know that coefficient in terms of 40, so this coefficient is 5 times, so this coefficient is 5 times another coefficient. And we see that here k minus 4, k minus 5, so k comes here, this part goes to the right with division, and we have this expression. You can use calculator to calculate it. Straightforward. So clear, no, doesn't work clear. Okay. 2 times second, quit, second. Right, now it is clear. Right, okay. So 5 times 12 mass probability to the right, probability, and we need line 3. 7 times 2 raised to the 7 divided by Let us put bracket. Here we have 12C8, 12 mass probability, line 3, 8 times 2 raised to the 8 bracket closed. 4. Correct answer. So we got 4. Right, now geometrical question. Let's put calculator aside. Right. So a communication tower T produces signals that can be reached cellular phones within a radius of 32 kilometers. A straight road passes through the area covered by the tower signal. The following diagram shows a line representing the road and a circle representing the area covered by the tower signal. Point R is on the circumference of the circle and SR are on the road. Point S is 38 kilometers and RST is 40. So actually we have this picture. Let SR be X. Use the cosine rule to show this expression. Hence or otherwise find the total distance along the road where the signal from the tower can be reached cellular phone. So it is distance from here to here. So I copied the picture. First of all, I draw radius TR. Now I have triangle. In this triangle, I have SR is X, TR is 32. So we write expression for cosine rule and substitute values and X. So we get this expression. Now we should find distance between R and S. It will be SR minus KS, SR minus SK. Right. On the other hand, SK and SR are solutions of cosine rule for this triangle and this triangle. So we use this triangle. So first of all, we will change in mode radians to degree because information is in the form of degree. So we move to degree. So I press mode. Now I go to degree. I press enter. So I change radians to mode. So I put here clear. Right. Okay. Now I should solve this equation and find two solutions. So I press apps. Again, Plymouth here line 3. Enter. Enter. Quadratic equation with real answers. So we go to next. So let's put X A1. Why is it okay? A2 is 1. Should be X. Coefficient in front of X is minus 76 times cosine 43. But closed. and the last element is 420, last term. Solve. So we have two solutions, and if we subtract these two solutions, we'll get what they ask. Finish this exercise. Second quit. Finish this exercise. Section B. Section B, we should split screen because answers are separately from solutions. Alright, okay. Question 8. Consider points A and B. Find AB. So AB will be B minus A. We subtract coordinates. We get the answer. Find value magnitude of AB. Magnitude of B, section 4.1 is x squared plus y squared plus z squared square root, and we can do it with calculator using brackets, and we have it. So it is 12.4. What else? A line has a vector equation. The point C is on the line. Find the value of y and show that AC equals this. Okay, let's see. This is B. So so x will be 2 plus t, y will be 0 minus 2t, and z will be minus 5 plus 2t. So we have equations. We need only two first equations. From the first we find that t equals 3 and then y equals minus 6. As we know, so we found y. AC will be C minus A. And point C we found that y equals minus 6. So instead of y we put minus 6 here, and we can find AC. Find the angle between AB and AC. So section 4.2, angle between two vectors can be found from cosine, which is equal to point product of AB and AC divided by amplitudes. So AC and AB are given by these coordinates. Scalar product, again there is a formula 4.2 for scalar product. You multiply each coordinate and add products of all coordinates. So you get these values. Then you calculate the magnitude of AB, of AC. AB you already know, AC you calculate. Then you put everything into this formula, and theta will be found as inverse function. Area of triangle, again section 3.6, half ABC and sine theta. So this is the answer. This question is over. Question 9. A nationwide study on reaction time is constructed on participants in two age groups. The participants in group X are less than 40 years old. Their reaction time are normally distributed with mean and standard deviation. A person is selected at random for X. Find the probability that the reaction is greater than 0.65 seconds. Normally distributed with mean and standard deviation so much. Find the probability that time is more than 0.65 means that 1 minus probability less than 0.65. Why less? Because calculator shows us this left part. Right. Okay. So let's do it. So we press second bars, and we need normal CDF cumulative. So line 2. So lower limit is okay, very small value. Upper limit we put 0.65. Mu we have 0.489, and sigma we have, enter, and sigma we have 0.007, enter, enter, enter. But we need 1 minus, so we put 1 minus, and our result, second minus. And this is what we need. 3 significant figures will be 0.107. So this is the answer. So this we did. Right, okay. The participants in group Y are 40 years old. The reaction times are normally distributed with mean and standard deviation sigma unknown. The probability that the reaction time of persons in group Y is greater than so much is 0.396. Find the value of Y. So here we will use Z function, Z parameter. So this is our normal distribution. It will be the same but standardized distribution with mu equals 0 and sigma equals 1. So we should find how much should be Z to get the same value of probability. And Z and this X are linked by this formula. Okay. So they say that probability is more than 0.65 equals so much. It means that probability that less than so much is 0.604. So we are going to use this information because our graphs are for less than, so distribution. So first we find the corresponding value of Z. So second bars, we use inverse normal 3. Area probability we have 0.604, and standardized normal distribution mu 0, sigma 1, pace. So how much is this value Z? This is this value Z, 0.264 with 3 significant figures. Yes, so now we put this value here. X is 0.65, and we should find sigma out of this equation. So we find sigma, it is 0.220. The probability, so this we did. In the study, B we did. Let's check. B we did. A and B we did. Now we need C. 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 Okay. A randomly selected participant has a reaction time greater than 0.65. Find the probability that participant is in group X. This is conditional probability, and we will look at tree diagram. This is a tree diagram. Before that, they say that 38% of participants are in group X. So when we choose participant, it can be either X or Y. So then it can be either more or less. So conditional probability, so we know that it is more than 0.65. So we should add this probability and this probability. This is the condition. And probability of the event itself is this line. So we divide probability of this event by probability of condition. After calculations, we get the value. So this is the value. Probability that randomly selected participant has reaction time greater than 0.65. 10 of the participants with reaction times greater than 0.65 are selected at random. Find the probability that at least 2 of them are in group X. 2 out of 10 with fixed probability of success. We have binomial distribution. Number of trials 10. Variable is X, and probability of success is our previous answer. At least 2 of 10 is probability at least 2 is X is more or equals to 2 equals 1 minus probability X less or equal to 1. Now we're going to use binomial's cumulative distribution function. So second was binomial is, let us scroll up here. So we should go to B. Binomial cumulative distribution function. Number of trials 10. Probability is 0.0163. X value is 1, less than 1. And let us see what we will get. But we remember that we should also subtract this from 1. So 1 minus second answer. Second answer. So 110 with 3 significant figures. Finished with this exercise. Okay, here we have graph. So consider the function between -2 and 2. The shaded region is enclosed by a graph of f, so from -2 to 2. A container can be modeled by this function. Find the volume of the container. So a container can be modeled by rotating this region about by 360 about the y-axis. Find the volume. Okay, question 10. So section 6.5, volume of revolution about x-axis from A to B is given by this formula. So integral, and we get 4/3 pi. The water can flow in and out of the container. The volume of the water in the container is given by the function gt, where t is measured in hours and gt is measured in meter cubes. The rate of change of the volume of water in the container is given. So g by gt can be positive, negative, and tell us how much in seconds volume changes by this formula. The volume of the water in the container is increasing only between p and q. Find the values of p and q. So let us draw this function. So what is the function? The function is g prime. Okay, let us draw this function. So we press y1 0.9 minus 2.5 cosine 0.4 time squared and time is between 0 and 4. This is why before drawing we go to Windows and we put here from 0 to 4, draw. So you see at the beginning the water is going out. I think I did something wrong. Because it looks like constant function. Let's check what is wrong with function. Uh, 0.9 minus 2.5 cosine 0.4 x squared okay, actually it should be, let me switch on this calculator and switch on again. Clear. Y equal 1 equals 0.9 minus 2.5 cosine 0.4 x squared bracket closed. Windows from 0 to 4, from 0 to 4. Draw. Now it draws correctly. Something was wrong, so you should you should switch off or clear random memory to set the calculator back. So we see that positive is between P and Q. So P and Q are zeros. So we press second calculate, and we need 0, 2. Here they need left boundary and right boundary, so we can see that the boundary is between 1 and 2. Guess. This is the first value, 173. Now second calculate. Second calculate. Second calculate. 0 again. Second 0 is between 3 and 4, so we put 3, enter, and 4, enter. Yes. And value is 356. So we did this exercise. Next question. The volume of water in the container is increasing only when, so we found values P and Q. During the interval from P to Q, the volume of water in container increasing by K. Find the value of K. So we should find integral from beginning of water incoming and end of water incoming. Finite integral is alpha Windows finite integral, and then you put values very easily. Don't forget brackets, don't forget with respect to which variable. Probably it will be x, for sure it will be x, right. When time equals 0, the volume of water in container is 2.3. It is known that the container is never completely full of water during the 4 hours period. Find the minimum, so it was hours, not seconds, sorry. Find the minimum volume of empty space in container during the time of 4 hours. So we see that here the water was incoming, so maximum water was at time Q and minimum empty space. So expression for empty space will be volume that we found before, 4/3 pi, minus 2.3 at the beginning, and then from the beginning till time Q, how much was incoming water. We make integral, alpha trace, enter. So not trace, we don't need trace, so you can do just calculation of this integral and you will get this value. Paper is over. Thank you for your attention. See you next time.